Okay. A very good morning to all participants, speakers, and co-organizers. I am Dr. Viraj Gala, Marketing Manager for Biomall.in. I wish you are all safe and in good health. We welcome you to the webinar series Sustainable Biosolutions 2020, jointly organized with the Department of Biotechnology, Beltech Rangarajan, Dr. Saguntala, R&D Institute of Science and Technology, and Biomall.in. The main objective for this series is to expose students, professionals from industry and academia to the different aspects of sustainable biotechnology. So we would like to begin with a short introduction about who we are. Biomall.in in India's first and now one of the world's leading online portal for laboratory, life science and diagnostic products. We have 1 lakh plus products from more than 200 brands across 100 plus categories, mainly chemicals, microbiology, genomics, proteomics, chromatography, diagnostics, lab consumables, lab equipments, even lab services. And now we also have a dedicated page for Corona Essentials, where you can find all kinds of products like masks, sanitizer, disinfectant, RNA isolation kits, PCR kits, reagents, and much more. Now I request Ms. Sai Nandini, faculty at the Department of Biotechnology, to please introduce Beltech Rangarajan, Dr. Saguntala, R&D Institute of Science and Technology, and continue with today's session.
Thank you, Dr. Viraj, and welcome to all. We at the Department of Biotechnology, Vailtech, Rangarajan, Dr. Shakuntala, R&D Institute of Science and Technology, Chennai, are happy to webinar in association with Biomall.in. Vailtech, Chennai was established in 1997 by Dr. R. Rangarajan and Dr. Shakuntala Rangarajan. This institution is a private deemed to be university and is ranked number 5 in the country by MHRD for innovation, has a diamond rating from IGOT, 43rd among Asian universities in Times Higher Education World Rankings. Our Department of Biotechnology aims to create and promote upskilled graduates with a professional attitude who are industry ready. Now, we are happy to introduce the speaker of this session, Shri K. Divakaran, Vice President Marketing, Acclaim Technology Services India Private Limited. A pioneer in the field of bioenergy, Divakaran sir has been associated with Acclaim Technology Services India Private Limited since 2004. Acclaim Technology offers renewable energy solutions based on biomass, combined heat and power, biodegradable waste to energy for cooking, heating, chilling, and power, solar thermal for process heat. Today, Mr. Divakaran will be talking on biodegradable waste to valuable biogas using BARC pattern.
I would like to thank Mrs. Veltek Rangarajan, Dr. Shakuntala, R&D Institute of Science and Technology for giving me this opportunity to address this webinar, and Biomal.in for facilitating this. We are talking about Sustainable Biosolutions 2020, and I am happy to make this presentation on sustainable bioenergy through biogas. The presentation is self-explanatory, and reading of the slide will make everybody understand what we are talking about. We are today fighting against an invisible enemy. We have invested crores in destruction equipments, but we have found that these are useless in today's world. And sustainable solutions are essential as we see more and more of the animal kingdom coming to the roads because we have occupied their habitats. So sustainable bioenergy is the energy of the future, and the more we focus on that, we are going to make this world a livable space. And bioenergy is the energy of the future. Visible?
Yes.
We are today, sorry for the delay, the bioenergy from kitchen waste, which is actually before cooking, we have the peels. Then after cooking, we have the food waste, plant waste, animal waste, and human waste. These are the biodegradable waste, which can be converted into a clean, green, and renewable energy. We have gone through the Stone Age, Bronze Age, and now we are going through the garbage. So dump yards are the main cause of water, air, and land pollution. These are waste generators, and the types of waste that are accumulated every day and how that can be dealt with technologically is what this slide is all about. So we have biodegradable waste and the non-biodegradable waste. Today's presentation is basically on how to handle the biodegradable waste, though there are solutions for non-biodegradable waste too. So in biodegradable waste, we have the fast degradable ones, that's food waste and animal waste, and which we are using biomethanation technology. So this is the solid waste generated per capita per day in any community, about 4 kgs. And sewage waste generated per capita is about 150 liters. Biodegradable waste is that which can be broken down into its base compound by other living things. We have explained this in detail. So now let's look at the detail. We have explained it in brief. Now let's look at the details. Food waste, vegetable cut waste like peels, rotten leftover of rotten foods, leftover of cooked food, and decayed foods. Water waste, from vessel cleaning, washing vegetables and grains, and plate wash. Only thing that we have to ensure is that we don't use chemical detergents to clean up these things. Animal waste, cow dung, chicken waste, fish, pig, horse litter. You think of it, and that it can be used here. And human waste, stool and urine. Chemical-free flushing should be ensured, else it will destroy the bacteria that aids in the digestion. Source of slow degradable waste, that's from grass, garden trims, dry leaves, sawdust, rice, stalk, fawns, etc. If you look at the crops that we produce in India or anywhere in the world, they can be classified as food products and commercial products. So food products are that we consume for our daily living, and the commercial ones are that we use for our dressing and other things. So any of these things, the usable portion is only between 20 to 30%, and the balance is a waste. What do we do with them? We either mulch them and put it back into the ground, which over a period of time gets decayed, and that is also the cause of pollution, or we burn them up. When we put them into the land, the gas that evolves is methane, and it is 20 times more dangerous than carbon dioxide. Waste paper should be shredded and mixed with cow dung to be made into a homogeneous product. Municipal solid waste, this is the most important thing which has got a solution. Only thing is we need a mindset and an attitudinal change to see that these are converted into a profitable gas. Today, people think that this is a resource by itself and it should be a generating model for a revenue generating model. It is not so. Actually, there should be a money spent on this to see that this is profitably used. Most of them talk of ROI in the waste management system. That's a misnomer. What we have to think only is about the waste management and how to profitably use that in industries. This is one of our projects where it's a 1 ton project where 1 ton of biodegradable waste is handled, and this is saving around 1,000 LPG cylinders a year. And this detail we will be giving in the coming slides. So this is the flow chart where the waste is put into a collection tank, and then this goes into a pre-digester where the product is homogenized and aerobic digestion takes place, and then it goes into an anaerobic digester, and from there it is retained for about 20 to 25 days depending upon the mix, and then what comes out is a gas which can be stored and used, and liquid manure which can also be converted into a solid manure. It's very highly nutrient rich. The gas can be used for either power or can be stored in cylinders, transported and used as fuel, or directly used as fuel also. When we have to use it, fill it in cylinders, we have to do a further processing of cleaning up this the gas. This is the gas balloon which we normally use, and the sizes vary depending upon the size of the plant. So biogas composition is what we are seeing here. It's mainly methane, 65 to 70%, carbon dioxide, 30 to 35%, hydrogen sulfide, and water and traces. Biogas does not contain sulfur, so it is considered a clean fuel. The gas can be cleaned and filled in cylinders depending upon the use. It can be directly used up to 100 meters if it is within, if the gas, if the plant is set up within the industry. But most places, the volumes, when it increases, that is not really possible to consume the entire thing. So what we do is we fill it up in cylinders. There are a different variety of cylinders, but the standard ones are 12.5 kgs, and a 4-cylinder becomes a cascade, which are easy to transport. So this gas can be put to different applications. When it is used at site, we use a normal burner. Sorry, it's not a normal burner. It's a lean gas. So we have a bigger holes that is used in the burning, and it can be used in the boilers also. It can be used for cooking. The different uses is what I'm explaining. It can be used for drying. We normally use this in tea industries and other drying applications, process drying. In air conditioning, using a VAM, technologies have evolved where we have the latest vapor absorption machines also, where steam can be converted into chilling requirements. Gas engines, clean and green power. 100 m³ biogas can power 125 kVA genset for 8 hours. So that's the type of waste to value proposition that we are talking about from waste. This was used in World War II in automobile for mobility also. So the application of this waste to energy is there in every industry, and every industry is also a waste generator. So liquid and solid waste are generated from these industries. Animal industries are chemical industry, paper mills, sugar industry, abattoir, poultry farm, fish market, vegetable market, and gardens. A typical saving plan is shown here. I have taken for a standard about 1000 kg of waste processed per day, where we get an equivalent of 48 to 50 kgs, which at today's market price of 65 kgs, there is a daily saving of 3,120 rupees, or an annual saving of 11 lakhs and 38,800 rupees. Normally, an ROI for this type of renewable energy projects is less than 3 years, which can be taken as a reasonable standard for investment, because loans are available, Swachh Bharat funds are there, and clean energy funds are available for industries. Or it can be a parallel industry where high net worth individuals can be requested to invest in the project with the collaboration of the industries concerned, and the heat can be used for their process. The solid, about 8 to 10% of the input, and liquid byproducts are nutrient rich and can be used for gardening. We have standard packages available for these biogas plants, which I will show you in the future slides, and in custom engineered for large sizes, smaller ones in HDP, where we can use it for hotel, canteen, cafeteria, and community kitchen. These are some of the models that we have created. This is a 500 kg in TNPL kitchen, where it is used for their cooking purposes. SSM builders are a community of around 3,000 houses, where they are using this entire thing and taking it to their kitchen. Biogas plant set up in Kalyan for Godrej under the CSR project. So this is a view of the plant. I can show you a video of that plant later if time permits. So now this is the STP plant, which is a plug and play, fit and forget type. It has got a lifespan of around 15 to 20 years, and it can be installed at any place. And as the volume increases, you can transport it, relocate it. You can do whatever you want on this with the plug and play model. And this is very ideal for 100 kg to 1000 kgs. Even for multiple of thousands can also be done, but cost-wise, it cannot be justified. So the technology we are employing is BARC technology, Nisarguna, twin digester technology, and DRDO's advanced reed biotechnology, and Ecogia of Japan. So water treatment also is possible using this technology, municipal wastewater treatment. We can use that in the biogas plant also as for moisture, to improve the moisture content and homogenization of the waste, sludge management, treatment of industrial effluent, agricultural effluent, landfill leachate, kitchen, food, plant, animal, and human waste. So DRDO's biodigester with reed bed technology is accepted for implementation on a national level by Indian Railways, Ministry of Drinking Water and Sanitation, FICCI, and Ganga Action Committee. So these are the advantages which are coming with this: biodegradable waste processed at source without creating any environmental impact, zero waste concept, transporting and dumping eliminated, 100% foolproof system of waste handling. The plant can be constructed underground without space wastage, environment friendly since the process does not generate any polluting liquids or gas, simple to operate, almost zero maintenance. So these are the advantages which comes with the thing again: proven technology, practically sound, eco-friendly, maintenance-free, cost-effective, no electricity needed, minimum maintenance, self-sustainable, aesthetic appeal, no mosquitoes, no odor. So these effects change with what is the input and what are the end requirement of the gas. So Acclaim, in association with NR Biotech Mumbai, is helping to set up integrated waste management projects in panchayat, municipalities and corporations under Swachh Bharat Abhiyan. And the fund is released directly to the municipalities through the National Institute of Rural Development and Panchayati Raj. The advantage of this is the projects are without tender, which is the USP. So if you can work with the panchayats, corporation or municipalities, we can take this up as a model plant and execute it for them. So take responsibility, join hands to mitigate the effects, and let's work to make this world a safer place to live in. These are my contact details. I'm available on these numbers, which is also a WhatsApp number. So thank you for your patient listening. And if you have time and if you would like to see the video of the plant, I can show that to you. Thank you, ma'am.